I'm Julia Stumpf, an instructional design librarian with Ruth Lilly Medical Library. This is the third video in our evidence-based medicine prognosis video series. In this video, we will go into more depth about Kaplan-Meier survival curves, and we'll explore how these curves can help us see prognosis over time. To start, let's talk about the Kaplan-Meier curve, which is a visual representation of survival data. Survival curves help us understand prognosis over time and can be a helpful way of presenting prognosis results. The question answered by a survival curve is, how does the likelihood of survival change over time? As mentioned in a previous video, information like 5-year survival, median survival rate, and observed survival come from survival analysis. Often these numbers are found in survival curves, which are found in prognosis studies. The curves provide more information than absolute or relative prognosis values because, in addition to a point-in-time prognosis estimate, you can get information from the shape of the curve. This is a very basic survival curve, or Kaplan-Meier curve. On the x-axis, time is measured in years, and on the y-axis, survival is measured between 0 and 100%. Each step downward represents an event, often mortality. However, it can be other events, both positive and negative. The tick marks in the middle of some of the horizontal lines represent censored patients. We'll go over what censoring means a bit later. We can determine median survival by finding when half of the patients have not had the event of interest and half of the patients have had the event of interest. To determine median survival, you can draw a horizontal line until it hits the survival curve, and then draw a vertical line from there down to the x-axis. In this chart, that seems to occur a bit after 1 year. We can also determine things like 1 year or 3 years survival. For 3-year survival, a vertical line is drawn up from 3 until it intersects with the survival curve. Then a horizontal line is drawn from the intersection point to the y-axis. It looks like 3-year survival might be a little under 10% of patients. Sometimes a Kaplan-Meier curve includes the number of patients who haven't had the event of interest at each point of time in the study. This is the number of patients who could potentially still have the outcome. This shows that as time goes on, the number of monitored patients decreases, affecting result precision over time. Let's look at some more examples. Here we compare two populations, S gene positive and S gene negative, and how long they live after testing positive for COVID-19. From looking at the curves, people who were S gene positive lived longer after the first positive COVID test result than to people who were S gene negative. Notice that these aren't smooth curves. They are actually more like steps consisting of horizontal and vertical lines. When there is little data, survival curves look like stair steps. If there is a lot of data in survival analysis, they might look more like curves because it is hard to see all the steps. In this figure, you also see some tick marks. Again, that indicates censoring of data. Another example, survival in acute myeloid leukemia over weeks. Notice a dramatic drop in survival with many patients not surviving past 50 weeks, maybe 90%. Those patients that do survive past 50 weeks also survive to 150 weeks. Notice again the tick marks on some of the horizontal lines that denote censoring. Note that the figure on the left shows fairly flat survival curves in the beginning of the study, and the figure on the right shows a very steep survival curve at the beginning of the study, and neither figure provides the number of patients remaining at each time point in the study. Now to explain censoring. The tick marks in the horizontal lines show when we lack exact survival data. So censoring occurs when we don't know a patient's exact survival time. And that can happen when patients are still alive or haven't had the event of interest at the end of the study, patients are lost to follow-up, patients experience different events, perhaps death for reasons other than the event of interest, have a bad reaction, etc. So that is survival curves in a nutshell. In our next video, we will spend more time looking in depth at survival analysis and comparison of two populations.